This is the effects of technology-based math interventions on fourth grade math achievement by Kristen Johnson, graduate student at Morningside College, BA in K-6 Education with a minor in Educational Technology. How can technological interventions improve math achievement? According to a study done by NAEP in 2016, students are not reaching proficiency in mathematics, and they're not making significant gains by the end of their 8th grade year. So the NAEP study goes into classrooms. They test students at the 4th grade level and also at the 8th grade level. And what they're finding is that students are not showing significant gains in growth between 4th grade and 8th grade. So they're trying to find ways to address it and meet the needs of those learners. Also, according to TIP and PISA, they show that the United States is rated low in math proficiency compared to other countries in the world. The United States is in the top 20. However, we have a huge point deficit between the top contender of Singapore and with ourselves. So there's a huge point difference between how we're performing even though we're in the top 20. So what is the impact of poor math performance? Gaps in learning lead to gaps in society. If a student is behind in mathematics and in other subject areas in their younger years, it is proven that they will be behind the rest of their life. So that's something important to consider. Also, capabilities in mathematics are linked to productivity in the workplace. If a student is able to encounter a problem head-on and have critical thinking skills and a good tool belt in order to solve problems, a student will be more productive in the future workplace. Also, it's important to note that careers incorporating mathematics earn 19% more than those that do not. Another issue is with curriculum reforms. There's a constant changing of curriculums in school districts, but what research are finding is that no long-term studies are done to prove the effectiveness of the curriculums. Also, it's noted that school districts do not measure a program's success after they implement it. So they just recycle through different curriculums without really making sure that they're effective or what they're helping their students to achieve. With mathematics, we're also lacking the ability to form personal connections. So it's proven that when students create connections, they are also able to create long-term learning. When a student connects what they learn to their background knowledge, they're more interested in it. They're also more engaged and confident in learning about the topic because they know a little bit about it. So if a math problem incorporates a grocery store, a student that has been to a grocery store will be more interested because they're like, I've shopped for cereal. I understand what we're talking about. So it's important that students are forming personal connections to the mathematics that they're solving. And it's also incorporated that 95% of students are currently utilizing technology. So technology as a tool. So we have technology at the top of the pyramid. And using technology, it shows that we are also connecting to the theory of constructivism by showing that students are active participants in the process of their learning. It's also shown that technology allows for deeper learning, so students are able to more deeply connect to a topic. Along with being active participants, we know that students are active participants because they can receive and give immediate feedback. A teacher can easily communicate with a student on their gaps that they're missing, as well as the technology tools that are used. Technology also allows students to collaborate freely, and they can collaborate with students internationally, with students in the next room over, or even students that are right next to them. So students are able to collaborate and share ideas more freely. Along with deeper learning, technology allows abstract items to be more relatable. A student is able to research the topic and is able to also find a solution. They have critical thinking skills. A teacher can assign a project or a question, and students are able to research and find the answer. So the student is in control and guiding their own learning. So as far as this, it is shown that technology integration creates more successful schools. So schools that are using technology currently are showing much higher results than those that are referring back to traditional means of educating students. But in order for teachers to feel more comfortable with using technology, they need to make sure that the technology has their needs met. So a teacher wants to be confident that the tool that they're using is meeting the needs of the learner and the needs of her end goal, his or her end goal. So in order for teachers' needs to be met, they also need to have additional trainings. So teachers need to have technology trainings so they can build their confidence when using these tools. Studies also show that if a teacher has a positive attitude towards technology and its usage, that they'll have more positive results than those that do not. So if you're a teacher that grabs the computer and you are more confident and positive about using the computer, then it will have more positive results with your students. So the importance of technology integration. It's shown that 39% of students are currently using smartphones. And students are also digital natives. So a digital native is a person who grows up using technology. So students are using technology since the very beginning of their lives and trying to solve problems using that. So why wouldn't we use an educational tool that also meets the students' needs digitally? 31% of students also use their phones for their homework. And it's shown that technology is able to support all learners. So whether a student is struggling or if a student is a reach student, we're able to differentiate using these different tools. Technology also promotes higher level thinking skills within children, and studies show that students that utilize tools have higher level thinking skills with those with outdated or traditional teaching methods. So the purpose of this study was to determine the effects of technology-based math interventions on fourth grade students' math achievement. The hypothesis was that it was predicted that after using technology-based interventions for mathematics, fourth grade students would make significant gains on their Boulder Valley math screeners and their scores from the pre-test in the fall before the interventions to the post-test in the winter after implementing the interventions. The independent variable was the usage of the different technology tools while processing through different mathematical practices. The dependent variable was the test that was used, which was the Boulder Valley math screeners. The methods is that this was a A-B design, which gathered 4 sets of data using paired t-tests to determine and compare the testing sets and the results. The participants were 20 fourth grade students with 2 ELL students with varying socioeconomic status and different racial backgrounds. The tool that was used was a i2015 Dell 3120 computer with a 4 GB RAM system with 16 GB of storage and an 11.5-inch screen with a Google Chrome operating system. The technology tools that were used or the programs used were Khan Academy, Google Classroom, Prodigy, the Boulder Valley Math Screeners, and the Boulder Valley Math Screeners also came along with a grading rubric. So in all, there were 11 questions that students needed to answer. Each one was graded on a 3-to-1 scale, 3 being the highest, 1 being the lowest, with a total of 33 points. The procedure was that students would complete the interventions for 5 days a week for 20 minutes after lunch. There was check-ins through the online application, so it would communicate with the facilitator where students had gaps or what problems they were missing or being proficient in. And the students were also instructed for math during large group using Howard County Math and Engage New York. The results showed that in the fall, students had a mean score of 14.85 points out of 33. So that is below the failing mark, but that is what students scored, with a standard deviation of 2.498. So between the fall pretest to the fall post-test, where students were just undergoing large group instructions, you can see some growth from 14.85 to 16.45. Then from the winter pre-intervention score to the winter post, you can see a growth of 15 to 19 points with standard deviation of 4.0. And here's another graph that shows that. So as you can see, there is growth from both testing periods, but there is more growth during the technology intervention stage. So this graph right here, this line, is showing the standard deviation for each. So on average, students scored 9% higher after the interventions. Data showed that all students showed growth throughout the process, but the p-value was less than 0.01. And then if you compare the very beginning of the study to the end, you can see a huge growth between those scores, and we'll talk more about that later on. So connections to theory. This study was really great. It connected to constructivism because it was student-led. We know this because students worked through their topics based on their own specific needs. Students worked at their own pacing. They were able to work through problems for 5 minutes, 10 minutes, whatever they needed. And the students were able to explore the different topics based on their own gaps in their learning. It also connected to constructivism because it activated students' prior knowledge. Students took what they knew and built off of it, and students formed their own connections through the tool. Students were also able to reflect, which students acknowledged their areas of struggle and they moved forward based on their gaps in learning. And students were also able to share with other students about their struggles and the tools that were most helpful for them. So the implications is that these tools provide quick feedback. They increase the parent involvement as parents are connected on the app and the site, and it can be accessed from the home. It's standards aligned, so no matter where you're at in the United States or the world, you can use the curriculum that you follow and you can align these tools to meet those needs. It's grade level appropriate, it has built-in differentiation, and it's also fun and educational. The limitations of this is that there's no significant gains of the study or a p-value above 0.01. There's not enough time within the study, and we also had a lot of snow days and Wi-Fi connectivity issues, and therefore that would lead the researchers to believe that they're unsure of the results based on just these interventions. And the recommendations. The researcher would recommend that you do a longer study over time, even between grade levels. So maybe starting with students in the lower grades and then have two different control groups, have a control group and an experimental. So maybe have one half of the class do traditional interventions where they meet with an instructor and do small group instruction, and then have students also then work with technology. Also, it'd be nice if we could measure students at the end of third grade and use the third grade written screener. That way the test data isn't showing what students are learning in fourth grade, because that's a natural progression, but also just to show what the tool is actually filling in and what the gaps are being met. And it would also be nice to find more technological interventions that meet the students' needs. Here are the references used. Okay, so the researcher found that although students showed significant gains, there were no significant gains above a p-value of 0.05. So all students showed growth, but more needs to be done in the study in order to determine the effectiveness of the technology-based math interventions. Thank you.